to invite on stage Mr. Anand Rajagopalan, VP of Operations, T-Works, India's largest prototyping center. He'll be leading a fireside chat with Mr. Dhruva, Space's Chief Technology Officer, Mr. Abhay Egoor. Can we have both the gentlemen on stage, please, to take us through the next session? Everybody, please welcome with a thunderous round of applause, Mr. Abhay Egoor, co-founder and CTO Dhruva Space, and Mr. Anand Rajagopalan, Director Operations, T-Works. We can be a bit more louder. See, it's all about knowledge sharing. Thank you very much. Over to both of you, gentlemen. I am pretty sure that this pie chart is going to be quite interesting. As we can see, a lot of things are going on onto the stage right now. We've got the satellites for you to have a better showcasing and to have a better understanding too. We would like you all to wait for next 1 to 2 minutes so that we can set a few things. And once again, a very warm and a hearty welcome to each one of you, ladies and gentlemen. This is NASSCOM NASTech 2023 Future Through Tech Lens. And on that note, over to the speakers, please.
Thank you so much. Hello, good afternoon, everyone. Nice to have a music session after lunch. Abhay was just telling me it's probably so that we can wake everyone up. But I hope that this conversation will also be interesting. I'm Anand. I'm from T-Works. T-Works is a Telangana state government initiative. We are India's largest prototyping center. And the objective of setting up T-Works is to support companies like Dhruva, folks building hardware products and prototypes. So we have about 20 crores worth of equipment in the facility currently, and we'll be expanding to about 110 crores in the next 12 to 18 months or so. So I'm here with Abhay. And is there a video you want to play now or after some time? Okay,
Yeah,
so as an introduction, I'll
we'll
give it
have
to
a
Abhay.
video. Yeah, I think we'll just have a quick video to show everyone what we do at Dhruva and also probably some of our future plans. And then I think we'll just directly dive into some panel discussion and then open up the floor for questions post that.
Welcome to the beautiful city of Hyderabad. Boasting a unique blend of modernity and heritage, making it an ideal ecosystem for startups and a treasure trove of cultural legacy, all home to more than 10 million people from all walks of life. Over the years, we have observed how Hyderabad has opened its doors to many global tech giants. This thriving infrastructure provides access to cutting-edge technologies and a pool of diverse skilled professionals. The city offers a supportive ecosystem with numerous investment communities, incubators, accelerators, and co-working spaces. Initiatives such as T-Hub and T-Works provide mentorship, funding, and networking opportunities to budding entrepreneurs. The key point of interest to aerospace players in the market, the groundswell of vendors who have long been contributing to integral space missions over the last 40 to 50 years. These vendors, vetted and trusted by the Indian Space Program, offer crucial products and services that include provision of raw materials, testing, and crafting of critical components for various spacecrafts and subsystems, such as satellite platforms, spacecraft solar arrays, launch deployers, and Earth station infrastructure. Over the last few years, Dhruva Space has been working with various facilities, such as T-Works, various micro, small, and medium enterprises in Balnagar and industrial parks within the city to fabricate and test components to be used in spacecraft and space missions. All of these elements play a key role in Dhruva Space's full stack space engineering solutions. Indigenously developed full stack technologies represent the new space spirit of Dhruva Space, as we create exceptional small satellite systems to help space exploration technology meet human imagination and innovation. We've stitched together the three essential pillars of any space mission: the space segment, which is the building of the spacecraft, the launch segment, which is the deployment of said spacecraft into orbit, and the ground segment, which is the tracking of and communicating with this spacecraft as it travels through space. In less than 12 months, we have successfully launched 3 space missions, including our history-making Thibault mission, which saw the launch of the first 2 private Indian satellites, Thibault 1 and Thibault 2, authorized by InSpace to be successfully deployed into orbit. These landmarks are a testament to both Dhruva Space's vibrant and growing team and the ecosystem at large. Now, as we scale our operations and pave the way for mass manufacturing and building of larger satellite platforms, as well as spacecraft solar arrays, Dhruva Space envisions to set up the critical infrastructure necessary for the realization of full spacecraft systems in Hyderabad. This 280,000 square foot facility comes over a 6.5 acre land strategically located at the TSIIC Hardware Park 2, in close proximity to our key partners and customers, as well as the Rajiv Gandhi International Airport, Shamshabad. Dhruva Space has come a long way indeed, and we believe that the time for space is here and now, as we continue to make Dhruva for the world a reality through diverse payloads and distinct space missions.
I see that the mission, one of the missions was named Thibault.
Yes, that's right.
So just to give the audience a background, we know each other since 2016 or 2017. We both were working out of Begumpet. T-Works was set up in Begumpet, and Abhay, before he became a co-founder in Dhruva, he was running his own company, and that company was called Thibault. Am I right?
That's correct. Yeah.
So can you tell me how you went from your journey and Dhruva Space's journey, how you went from building these automation IoT systems in shrimp farms to building satellites?
Absolutely. Yeah, in fact, so contrary to most space tech companies, I would say, I think my personal journey or my professional career was not directly in space tech. In fact, I'm a graduate with an electrical and electronics engineering degree back in 2010. Post which a good chunk of my career was in embedded systems, largely building systems around for post silicon evaluation, etc. And around 2016 was when I quit my let's say corporate career and started my own venture called Thibault back then, which was primarily into building sensor based connected devices, largely IoT applications for smart industries including aquaculture, smart homes, etc. um, and it was during that time that I kind of reconnected with my old classmate, who incidentally today is the CEO at Dhruva, Sanjay. When he already had his venture in the space tech domain, having done his masters in space engineering, etc. And one of the key observations that he had done was that, what we were building for IoT or for terrestrial applications, like, all the electronic development that we were doing, or a bit of mechanical design for, withstanding all the humidity and various pressure ranges, etc., was something that he felt, with little bit of space engineering thought process, uh, uh, added as an element to it, is something pretty much what goes largely into a satellite also, systems that go. For example, if you look at a satellite that is there, size of what you can see over here, or slightly larger one over there, largely all the subsystems that go into them are like your typical power system, solar panels, like an onboard controller, and an RF subsystem. Something not, very unusual, or not terms that you're not very familiar with anyways. So it was all about packaging them into the right form factor and designing the various other mechanical support systems that can withstand the harsh launch loads that they experience during rocket launch, is what we had to kind of take care of. And that was something which happened as a transition when we were initially doing IoT based comms, and we saw a gap where we initially thought of building a satellite communicating module for ground, and then it kind of took us to a level where, at one of our meeting, we just thought, why don't we build a satellite? And that's how we kind of, the teams got together, and eventually, we merged Bolt into Dhruva Space, kind of formed a completely new team. We raised the first round of capital, and then, over here, after launching 2 satellites.
Fantastic. So sometimes the discussions might get a bit technical, but we are also open to questions. You can keep your questions. I think at the end, we have a Q&A round also. So you can write down your questions and then I'll help moderate that. So tell me, I am unfamiliar with space, and actually we have a few space startups working out of T-Works as well. How different is engineering for, say, terrestrial or underwater or whatever, engineering for Earth versus engineering for space? And how, if someone wants to get into the industry today, how steep is the learning curve?
Yeah. Um, I think to answer the second question, the second part of your question first. So I'm like literally the one of the examples of someone who was started in a non-space industry there, but eventually today, being part of one of the first India's space tech companies, I would say. But having said that, today, uh, what we are looking at is a kind of an inflection point where space is no longer being looked at as one of a national agency driven industries. Like, if you look at it historically, probably even in early 2000s, when you talk about space, you only knew, let's say, ISRO in India, or NASA in the US, and European Space Agency in the Europe, etc. But today, all these national space agencies, while they do have their own programs, it's equally dominated by a multitude of private players in the industry across the globe. And we see some of them coming up in India as well. So this shift has happened due to multiple reasons, which I'll probably elaborate in the following, the next few, hopefully in the next few minutes. But largely from a design point of view, if you're looking at it purely from a technical point of view, most of the subsystems that we build, like I said, do take their basis on like most of the terrestrial systems, but we just have to take care of, or rather we take care of two major criteria, especially from the environment point of view. The first one, any satellite that has to be launched into space has to first withstand the severe launch conditions, or the launch related vibrations that the system experiences of the launch vehicle during the launch. So the first part is that it has to withstand that, but at the same time it has to be extremely light, as light as possible, because sending anything to space, it's money, the weight is directly proportional to the money you want to spend on the launch. The second part, most of the subsystems inside have to work within a vacuum condition, across temperatures ranging from, let's say, minus 80 degrees to plus 80 or 100 degrees. So all the subsystems are expected to work in thermo vacuum conditions. So we do simulate, or rather, in fact, we put all the systems in a chamber that are designed to simulate the same space environment. And the third thing is on material selection, where we use all the materials that are flight proven, or some of them, for example, have what is called as a very low outgassing properties, that they don't go out and pollute the outer space. So these are some of the broad design criteria that we take care for a satellite development.
And information about this is available for someone to learn and get into it, or how hard do you have to search for information if someone has to get into the field?
So I think from a standards point of view, or information on design guidelines, um, we actually resort to what is called as ECSS standards, which is the European set standard for most of the space developments. So, for example, there is a huge amount of literature that is open source or like openly available. It's a public portal where you can download every single standard for guidelines on how a particular system has to be either designed or especially fabricated. Of course, the design architecture is our own, but when it comes to fabricating it and due care that has to be taken while realization of subsystems, we take shelter under the ECSS framework currently. But there are similar open source standards by NASA as well. And within India, now it's very recently, in fact, I am one of the panels constituted by the government of India, where we are developing the similar standards within the Bureau of Indian Standards for space technology, which are taken from the ISRO standards right now.
Fantastic. So I see on the table here 3 different satellites,
Right.
or
Space systems, you can call them
space systems.
spacecraft. Yeah.
Okay. Can you tell me why they are of varying sizes, and how does the size affect what kind of satellite you put out there?
Right. I think probably we've let the cat out of the bag by having them over here on display. But if I had asked a question to the general audience at large, what is the first thing of the size, size that would come to their mind when I talk about satellites? I think most would, probably think of a small SUV or a, small car kind of a sized object, what we call as a satellite. But over the years, what has happened is, thanks to the advent of semiconductors, advancements in the computing capabilities of various semiconductors that we're seeing today, like, what kind of revolution that happened within, let's say, your mobile phones or computers, etc. A similar kind of trend has happened within the space industry, where today we are able to launch a satellite that, I'm literally able to hold in my hand over here. And this is not like a scaled down version of a satellite that you're able to see. This is, in fact, a 1:1 model of a satellite that we had launched pretty much exactly 1 year as of today. We launched them on November 26th. And we've almost finished about 5,500 orbits around the Earth as we speak today, and they're still functioning. So this is what today we are capable of from an engineering perspective. And um, yeah, I think largely that's been the major trend in terms of form factors. One of the reason why you see a smaller size over here and a larger one over here is largely to do with the payload and its applications. For example, this targets something like a very low data rate, like an SMS or an IoT based communication using these satellites, whereas we are targeting applications like Earth observation, imagery, and slightly more sophisticated communication payloads using probably the size of what is like a desktop printer, as we call it. It's a P30 model. So from that kind of a platform, which gives more power than what this can do, etc.
So from Dhruva Space's perspective, you are building satellites itself that have an application, but you are also building things like this that you told me is called a bus. Can you tell me a bit more about what is a bus and what does this satellite do?
Right. So today, why do we launch satellites to begin with? Right, they are solving a particular problem on ground. Take for example a constellation that is giving you your GPS network. Today, any mobile phone that you go out, you're able to pinpoint your location, which is a satellite based application. Similarly, what you see on your Google Maps, or an imagery of the earth, like a satellite imagery, that you're able to get a refresh every 1 day or every 14 days or whatever. So these are various applications that are possible today because of satellites. What we call ourselves as within Dhruva is, when we say we build satellites, what we do is we build application agnostic satellite platforms, which means that as a company, we don't launch a satellite for a specific application. We are not in that business. But if anyone, whether it is, let's say, an enterprise customer, or defense customer, or any national interest for disaster management, etc., if they want a specific application to be solved using a satellite, we build a satellite platform which includes, let's say, your solar panels, your electrical power system, onboard controller, RF subsystem that sends the data back to the ground, or one other very critical subsystem called your attitude determination and control system, which kind of stabilizes the satellite platform in orbit, and then effectively allows the payload which we get from the customer itself, or any other vendor or partner with whom we are working with. So we integrate their payload into the satellite bus, while the rest of the systems around it are built by us, and then we help them launch it, and then they take over to perform their application.
So over the last few years, you've been building this, you've already launched 3 satellites. What have your learnings as a budding space tech company been? And a related question, how has it been like working with ISRO? You
Right.
may be as diplomatic as you want, or you can be as honest as you want.
No, again, yeah, I'll come to the ISRO part, in a short while. But I think being part of space missions, as an individual and also as a company, when when we did our first mission sometime last year in June, before the satellites were launched, we were a team of about 30 people, and today we are about 80 of us. But largely, when I look back on the first mission, I think it is a story of sheer perseverance, or I think that was one of the biggest quality, I would say, as a space tech company, or any one, be it an engineer or a co-founder, or any of the support staff who are equally important, in every role that we have played. I think the biggest uh, quality that we look for are two major qualities. One is, like, a perseverance, where we are talking about extremely long gestation periods for a project to be executed. And number two, um, iterate very fast, and kind of fail fast, iterate fast, and then be in a position to uh, you know uh, have your system on the rocket. To be able to do that final step itself is a huge iterative effort, I would say. And the second quality is also on your sheer focus or priority on quality assurance. So it's a game of zero compromise or zero tolerance to any errors, because unfortunately we cannot go back and fix anything that's been launched. So quality paramount, and focus on that has been exceptionally high within the company to be able to have back-to-back successful missions. So the last 3 missions that we have had. So yeah, and working with ISRO, I think we've been extremely fortunate to have 3 missions on the PSLV. In fact, until the last PSLV mission, we had a satellite or a subsystem of ours on every launch of PSLV that they've had since June of 2022. So this is something we do intend to continue doing over the next few years, that we want more than one mission on every sat rocket that's been launched out of the Indian soil. And so far, it's been ISRO's been supporting us extensively. I think we personally have had an exceptionally great relationship with them. Not just because they were supporting us on the technical stuff for launching our satellites, but you must also understand that the Indian ecosystem or the Indian government has opened the doors to private industry very recently. So it's kind of a lot of learning or working together with the regulatory agencies and the government agencies like ISRO, InSpace, NCEL, like New Space India Limited, etc., where we are all like they're all evolving and building policies as we move forward. And in most cases, we were almost to an extent a guinea pig for them in terms of understanding how the policy is going to work, or in some cases we went with a problem around which they had to kind of introduce a policy. So in that sense, it's something that we are in it together right now, and we hope to continue doing more and more missions, not just for an Indian market, but from across the globe. Our motivation or our target is that we want to serve the global market using the infrastructure that we've built in India. So more launches out of India for global customers, hopefully enabled, some of them enabled by Dhruva Space, is what we're looking at as going down the line.
You spoke about going global and you spoke about long gestation periods as well, and a 30-member team becoming an 80-member team. Clearly, you would have needed some investments to get to where you are today. So I think even when we were interacting with some folks from the audience, one of the questions that automatically come is, okay, I'm enthusiastic about getting into the space sector. I have perseverance to get me through the initial 4 or 5 years. But what is the pitch that you would make or you have made to your investors? What is the market outlook like? How has the market evolved so that an investor can put in the kind of money you need to get to a stage where you are today?
Right. I think I still remember sometime in 2019 was when we raised the first round of capital for Dhruva Space. And even like, that was just before the pandemic. And what I recall from those interactions was that we pretty much had to meet about close to 160 investors before we convinced for the first check. And so it's one of the major reasons that had come in back then was that most of the investors are still forming their thesis around the industry. And while there was definite interest, while they were all curious to see how a small company can go on to become or rather build and launch satellites down the line, um, that final jump to or take that leap of faith to actually put in the money was not coming through as much. Today, I strongly believe that that narrative has changed thanks to some of the recent successes that the industry has seen, and also some of the proactive measures that the government has taken in terms of at least giving the policy clarity that we are very clear that we are opening the space for private companies to launch their own satellites, etc., which was not the case prior to June 2020. So it was around 2020 June or 2021 June was when a policy was floated that allowed private companies to be able to launch and operate satellites within the Indian soil. So I think this was the kind of confidence that the investors were looking. But having said that, ultimately now it is slowly becoming that mainstream business where you can go back and pitch like how you would pitch a regular company with your business plan, your problem you're solving, the solution that you have, and what's your return on investment or your kind of overall business plan in general.
So how has the satellite industry grown from, I don't know, the 90s to the 2000s and now? Can you share some numbers, some insights into how big the opportunity is?
Yeah, I think I'll just probably ask a couple of audience over here on that. um, so let's say the first satellite was launched by the Soviet Union somewhere in 1959 or so. But from that year onwards, if I ask any of you to take a wild guess on how many satellites have been launched, let's say until 2000 or 2010, um, anyone who here can throw a number for that? Sorry? Couple of hundreds? Yeah, I think the number stands at about 10,000. So between 1959 until 2010, there were about 10,000 satellites that were launched in about that 60 years or so, 50, 60 years. But from 2010 until, let's say, today or the last one decade, the number of satellites that were launched was more than 16,000. So this is the increase in the number of satellites. And it is estimated that in the next decade, you're going to see, at least with a conservative estimate, about 60,000, 60,000 number of satellites that are going to be launched into what we call as majorly in the low Earth orbit.
And I
So
think,
that's the numbers.
and what has accelerated this increase in the number of satellites? I mean, of course, many of us are familiar with SpaceX, reuse capabilities, and things like that. But I'm assuming it's something more also, right?
Yeah, the lowering of launch costs is definitely a factor, absolutely. But more than that, I think a couple of other major factors is that number one, again the advancement in semiconductors or electronics that today allow the same function that probably back in the probably in the 70s or 80s, that you had to build a very large satellite to achieve a certain functionality. Today you're able to achieve in a much smaller form factor. Let's say size of our P30 in some cases could actually do a operation of a satellite that probably was done by a 200 kg class satellite a couple of years back. That is number one. Number two, um, most of the satellites are being launched in what is called as a low Earth orbit, which is in the altitude of 400 to 600, 800 kilometers orbit, where the lifetime of the satellite is just 5 years, and then they deorbit and burn out. So, which means that any satellite that you launch has to be refreshed or relaunched or replenished every 5 years. That's number two. And number three, in the low Earth orbit, the satellite is not always at the same point relative to the Earth. Like, say, for example, if I launch it over in that orbit, in a 400-kilometer orbit, let us say the satellite passes over Hyderabad where we are sitting, and if it takes an image of our Hyderabad and as of today, to take exactly the same image, it takes about 14 days for it to come back and take the same image. And this is what gives rise to a factor that today we are not launching only one satellite, but we are launching a constellation of satellites to ensure that you have more higher revisit or more frequent revisit times, or that there's always a satellite above you to perform the operation. So the number of satellites per each of this constellation is increasing. So these factors have given rise to the number of satellites that you're looking at in the orbit, or projected satellites that are meant for launch in the next decade.
And what about the components that go into a satellite? I think my assumption was because it's going into space, you have to use radiation hardened ICs, or you have to use very specially designed components. But during our conversation, you said you have used off the shelf components also. So, how does that work? Can someone here build a satellite using off the shelf components?
Yeah, in short, I think to answer again your question, yes, absolutely. So today, the reliance on radiation hardened semiconductors or any component is slowly decreasing, because the modern day COTS components today, to an extent, when I say COTS, the maximum that we go to is like a mill grade component, where we those along with an additional layer of protection, using passive elements like what is called as an MLI sheet or an additional mechanical enclosure, etc., is more than sufficient for me to give me a 5-year lifetime. So I'm not building for a 20-year lifetime in a geo orbit where the radiation effects are much higher. Today we are talking about much lower altitude where the radiation effects are milder and lesser lifetime. So it's cheaper for me to actually build a COTS component based satellite, launch it, let it decay faster. I put one more in 3 years with a much better spec. So that's how, in a very similar to a smartphone industry, you're looking at, new generation of satellites going up with better spec every 2 years or 3 years, and achieve, the same application.
From a policy perspective, you are on some committees to decide on certain policy aspects. What is your wish list for the government, either state from an infrastructure perspective or the central government from a policy perspective, to accelerate your journey or the space tech's journey in general, either from a tech perspective or investment perspective, regulations perspective? What would your wish list be like?
Yeah, I think we've um I think we have most of the issues sorted right now from an infrastructure support point of view, both from a state government or the central government. There's good amount of initiatives for which we are part of and some of the beneficiaries of. Good policy updates on the regulatory part as well, by the formation of InSpace, and a very good as a nodal agency to communicate and coordinate for multiple of our queries and regulatory related hurdles. One of the things that we, as an industry, I think we're all awaiting, which we do understand that is in the at an advanced discussions or thoughts, is an approval of FDI. In whatever percentage, whether it's 49 or 74 or anything, but giving us the confirmation of, or rather approving that foreign direct investments, which is not there within the space industry as.
So how does FDI work right now? Say you're raising, have you raised money from through
Yeah.
FDI routes? And
So we did in fact raise money from foreign venture capital firms in our last round. But because there was no FDI available, we had to go through what is called as an FIFP, which is a, I think, foreign investment. It's like an approval route where we have to route the entire approval process through RBI and get clearances, and involve multiple agencies like your DPIIT, etc. Get clearances and get the money finally. So we closed the round in October 2022, but let's say, we finally, by the time we finished all the process and approvals, we got the money only in August this year. So it's like almost 8 months of time that we had to wait for the money to hit. So if FDI is approved, then we don't need to have, this uh, delay in our fundraising process. So I think this is going to greatly benefit the industry at large. And yeah, that's something.
so essentially, if I'm not wrong, you started in 2017 or 2018. You worked for 2 years with a high regulatory risk in the industry, and now you continue working in the industry with some regulatory risk. What does your horizon look like? When do you feel like things will be completely sorted, or do you think there will always be a risk in this industry for some time?
Yeah, I mean, we don't call it a risk per se. At least our business model ensures that we kind of mitigated this in multiple ways. For example, even when we were operating in 2019, when the regulatory framework was still not very clear, our business model was that we could still continue building satellites, but probably not launching it on our own. We would have to sell it to someone, whether a foreign entity or an Indian agency, etc., but not be able to launch on our own. So in that way, we still would have our revenue sorted, or we would still have our business model sorted or mitigating this risk. And we continue to hedge our risks in the same fashion that uh, if something on the policy or regulatory side works, we're more than happy to take it in our stride and work on top of that. And even if it doesn't, I think we are well sorted, or there's enough market within what is already approved that is keeping us busy.
So in these last few years, what would you say is the biggest achievement of Dhruva Space, according to you or according to the company?
I think staying afloat through the pandemic. I think, yeah, last couple of years have been quite intense, I would say, in terms of the kind of projects or the kind of yeah, missions that we had undertaken for ourselves. And today, I think the biggest sense of achievement that we have is when we look back and say that, you know, we had 3 missions in under 12 months, which today, even for most companies outside of India, also is a very, very big task or a big milestone. So having achieved it within the 3 years of formation, or, you know, technically, when I say formation, first 3 years of fundraise, I think we do consider that a very huge, you know, we have a good sense of achievement. And yes, as you had seen in the video, our ambition to set up a manufacturing facility and bring global OEMs to India, to Hyderabad, to serve some of their requirements. I think in the next year or two, when we execute that, I think that would be the biggest, you know, target for us in the next few years.
A small follow-up question to that. You are based out of Hyderabad. Skyroot is based out of Hyderabad. We are working with a few Hyderabad-based space tech companies. Um, uh, why Hyderabad apart from you are local here? And what in the ecosystem do you think attracts companies to come and set up over here?
So I think we yeah, one factor was that we were like locals to Hyderabad was one factor, but that was never actually a real factor in terms of finalizing the place. Um, One of the really important reasons when we evaluated was the ecosystem actually. So if you look at, I think most of you here would also be are more familiar from the IT or the software side of things. But on the other side, Hyderabad also has a very thriving ecosystem of MSMEs and large industries for aerospace and defense, which means that, I mean, there are a lot of defense laboratories and there's huge presence of certain aerospace companies that are around, like your Tata, Lockheed, etc. What happened because of these companies is that there's a huge ecosystem of medium and small scale industries that have mushroomed over, you know, areas like Balnagar, Cherlapalli, etc., which today have established already processes and infrastructure in terms of equipment, etc., that can actually machine all these subsystems or systems. Everything that you see over here, right from the separation system or the entire satellite structure over here, or the mock-up of a P-30. In fact, the main flight grade model also is all fabricated in Hyderabad. So that is the one of the major reason, and I think thanks to other initiatives such as T-Works and T-Hub, from for which, you know, we were part of right from the beginning. I think these factors definitely help us reduce our, you know, not cost per se, but the design turnaround times. So, for example, if it takes about 6 months in any other city, we would be able to work with our vendors to iterate faster and be able to reduce that to almost half of what we, you know, typically can do. So, I think these are major factors.
Thanks. Okay, they are saying time up. I think we have to leave the stage, but are there any questions from the audience?
So basically, we will be taking the question near the experience zone. Due to time constraint, we won't be able to do it. But then a big thanks to the presenters. Can we have a huge round of applause for the panelists, please? Thank you so very much. With this, I also request our speakers to kindly stay back with us for a moment. And can we please have Mr. Harshvardhan to kindly join us on stage and hand over the goodies as a token of appreciation from our side. Come on, ladies and gentlemen, that was an absolute presentation. Indeed, a lot of fruitful learnings. And if you have any question, any queries, then you can make a visit to their booth right outside and get your queries answered. Thank you so very much, sir. Thank you very much, gentlemen.